Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between static and instance variables in Java? Let me answer this question with practical demonstration. So what is the difference between static and instance variables? So instance variables belong to object memory, whereas static variables belong to class memory. Here, it's not class variables, it's static variables. Static variables belong to the class memory, whereas instance variables belong to the object memory. Coming to the static variables, they belong to the class memory because that is going to be a common memory. Okay, for all the objects, okay, for all the objects, if you want a common value, then you will not store that particular value in an instance variable. Rather, you will specify the static keyword before that particular variable and make that particular variable a static variable which belong to the class memory. Okay, common stuff should be part of the class memory, which are the stuff which can change from object to object. For every object, if the values are changing for that particular variables, such kind of variables we have to declare them as instance variables. The variables whose value will be same for almost all objects, that kind of variables should be stored as part of the static variables. Okay, so static variables belong to the class memory, that is common memory, whereas instance variables belong to the object specific memory. Let me explain all this stuff in a step-by-step practical manner so that you will be able to answer this particular question in a better way. Okay, for that I'll switch to the Eclipse IDE, guys, and here I'll expand this. Already one kind of package is there. So modifiers, in that modifiers package, I'll create one sub package, guys. I'll just create a sub package. I'll just name, okay, name this as dot something, anything you can say. Let's say it's already 7 is done. 8, I'll say 8 is not there. Some sub package 8. I'll create a new class here, guys. I'll create a new class. I'll just name this class as, let's say, car class. With this example, right, I will definitely understand when to make a particular thing as a static variable and when to make particular variable as an instance variable. You will clearly understand now, guys. Let me create this car class. This car class I'm going to use as a template or blueprint or plan or factory for creating objects. So let the car class get created. Once the car class got created, guys, inside the car class, I'll create some variables, guys. String company of the car, then string, what is the next one? Model. Generally, we deal about whenever you say about a car, right? You generally say company, model, then double mileage, int price, or double price here. Okay, double price. Then string color, Then the other can be int wheels, number of wheels. Okay, like this, some sample variables I created, guys. You can create hundreds of variables for the car class template, but I'm only taking few as an example. Here, along with this particular variables, guys, I'm also creating some methods, guys, like public void start car. Okay, here I'll simply write down system.out.println car from company. Which company? This company, this particular company, and having model. Which model? Having which model? This particular model. This particular model has started. Okay, then I'll create one more public void stop car. Here I'll write down system.out.println car from company, that is plus company variable. This is an instant. All these variables are global variables, guys. All these global variables are instance variables. Okay, if you don't specify any static keyword before any of these global variables, they become the instance variables automatically, guys. Okay, these are called as instance variables. Okay, so variables can be, I'll give you some examples here, guys. Variables can be categorized into two types at a high level. One is local variables, other one is global variables. One is local variables, is one type. Other one is global variables. Other type is global variables. Okay, one is local variables, other one is the global variables. The variables that are created inside the methods are called as local variables. The variables that are directly created under the class and outside the methods are called as global variables. For example, here, all these variables are global variables because they are directly created directly under the class and outside these methods. If you create a particular variable here, like if a is equal to 5, something like this variable a is a local variable, okay? But here all these variables are created outside the methods and directly inside the class. They are called as global variables. And these global variables can be categorized as different types, okay? That is, one is instance variables, which belong to the object memory, whereas other one is a static variables, guys. Static variables which belong to the class memory, which are common variables, which static variables are common with, they belong to the common memory, that is a class memory. Static variables, guys. If you specify the static keyword before these global variables, they will become the static variables. If you don't specify the static keyword before these variables, they become the instance variable. Both static variables and instance variables are global variables, but instance variables doesn't have the static keyword before them, whereas global variables having the static keyword before them are called as static variables. Okay, fine. Anyhow, for now, all these variables are of instance variables type, and I'll give you one example, guys, where you have to create the static variables having model. Which model? This instance variable model plus model plus has stop. Like this, I created some methods, guys. Okay, I created start car and stop car methods, guys. I'll also create one more method like print car details, okay, or get car details, whatever it is, get car details. Like this, you can create a method, guys. Okay, and here, whenever someone calls this particular method, right, all the details of the car should be printed. Let's say company of the car, company of the car is company of the car is plus company. Okay, then system.out.println model of the car is plus model. Then system.out.println, then mileage of the car is plus mileage. Then system.out.println price of the car is plus price, plus price. Okay, plus price. Then system.out.println color of the car is plus color. Then last one, system.out.println number of wheels of the car are plus this wheels instance variable here. Okay, like this I created, and the final, right, I'll just for separation purpose I'll add this line, guys. Okay, fine, this is all good. I created a car class template. You can see the car class template here. This is a car class template containing some sample variables and sample methods here. Now I'm going to create another class. I'll just name this class as demo class with some main method I'll create, so that I can create an object for this class and access these variables and methods and run the code. Okay, that's the reason I'm creating here. Now, guys, in this kind of situation, I'll just minimize this one. In this kind of situation, guys, okay, here I can create objects here using this car class as a template. I can create objects here, guys. For example, if I want to create an object for one of the real world object, let's say one of the car in the market that is there in the market, car HAMZ. This Honda company's Amaze car. Okay, Honda company having the model as Amaze. I'm just creating an object, guys. New car. Otherwise, yeah, Honda Amaze is called new car. I'm creating an object here. The moment I create an object, guys, in the computer memory, guys, let's assume that this is a computer memory. This is a complete computer memory. In the computer memory, some memory will be allocated to this particular object. Okay, this particular object, new car, right? New keyword will create an object for the car class, this particular class, and some memory will be created. Let's assume that this is object one. Okay, now if I say HAMZ dot company is equal to Honda, what will happen? The moment I say here HAMZ is object reference, which is referring to the memory location of this object one. So HAMZ is the object reference, guys. HAMZ is the object reference. Using this object reference, we can locate this particular memory and access all the variables and methods of that particular object. Okay. Now here HAMZ dot model is equal to Honda Amaze. Amaze is a model. Let's say Amaze is a model. Then HAMZ dot mileage is equal to, let's say, 14.5 kilometers per liter is a mileage, okay? And HMZ dot price is equal to let's say 9 lakhs. Then HAMZ dot color is equal to then gray color. Then HAMZ dot wheels is equal to number of wheels of the car are 4. Like this, I'll create, guys, all these variable values that are initialized for this particular object. They will be stored in the, since these particular variables are instance variables, the values of these particular variables for this particular object will be stored in this object memory. So here see, guys, what will happen. Company is equal to Honda. Model is equal to Amaze. Then mileage is equal to 14.5. Then color is equal to gray color. Price is equal to 9 lakhs. Okay, 9 lakhs is the price. And then wheels is equal to 4. Like this, I'll create. Okay, like this, the values will be stored because all these variables are the instance variables in that particular object memory. The values of these particular variables will be stored. Now, if I want to access the start car, stop car, get car details, right? Using the object reference, I can say HAMZ dot start car, HAMZ dot stop car, HAMZ dot get car details, Like this, I'll write. Okay. This is one object. So if I run the code, you see all the details of the car will be printed. Whatever the instance variable values I created, right, they will be retrieved and printed for this methods. You see, you can clearly see that what is the output we got. Car from the company Honda and having the model. Amaze has started. Car from the company Honda and having the model. Amaze has stopped. Company of the car is Honda. Model of the car is Amaze. Mileage of the car is 14.5. Price of the car is 9 lakhs. Color of the car is gray. Number of wheels of the car are 4. That's good. Now I'll create one more object, guys. Car. Otherwise, I'll simply make this, guys. I'll just copy paste these lines so that I can save some time here. I'll just name this as BMW X1. Okay. Now I'll create this BMW X1 dot company, BMW X1 dot model, BMW X1 dot mileage, BMW X1 dot color, BMW dot X1 dot wheels, BMW dot X1 dot start car, stop car, and get car details. Here I'll say BMW is a company and X1 is a model. And the mileage is only 12 kilometers per liter, and the cost of the car is around 60 lakhs, and the color of the car is black. Let's say black. Okay, and the number of wheels of the car is 4, and remaining all are same. So run this code here, and you'll see that for these two objects, you see all the details are coming, right? So in the computer memory also, when you create another object for the car class, right, this is what is going to happen. Object 2 will be created, guys. Object 2 will be created. Object 2 memory will be allocated, and the object reference for this object 2 is BMW X1 is object reference. BMW X1 is the object reference of this particular memory allocated to this particular object. And here all the car details will be stored. That is company is equal to BMW, and model of the car is equal to X1, and mileage of the car is equal to like 12, and color of the car is black, and then price of the car is 60 lakhs. Okay, 60 lakhs, and wheels of the car are 4. Number of wheels of the car are 4. Now, like this, I can create any number of objects, guys. I can create any number of objects. Okay, I'll create a few more objects, guys. Okay, few more cars, real world cars. I'll just represent here. Let's say I'll just take this as HY i20, Hyundai i20. Let's say. Okay, I'll just copy this and give all this Hyundai i20 object reference to initialize the variables, instance variables for that particular object. Okay. Then here I'll say HYU and A Hyundai, and here i20 is a model, guys, and here number of kilometers is 11, let's say, and the price of the car is like 11 lakhs. Okay, the color of the car is white, let's say, and number of wheels of the car are 4. So what happens here, guys? Another memory will be allocated here. Another object will be created, and for that particular object in the computer memory, some memory will be allocated. This is object 3, guys. This is object 3. Okay, I'll create few so that to understand the difference between static variables and instance variables, right? This kind of example is really required, guys. That's why I'm explaining all this stuff. Just be with me so that you'll understand the actual understanding out of what is a static variable and instance variables. If you simply give the definitions as an answer in the interviews, right, you may not be confident. with this explanation, it should be very clear for you. Company is equal to HYUNDA, Hyundai, and model of the car is I-20 is a model of the car. And then mileage of the car is equal to, mileage of the car is 11, and the color of the car is, mileage of the car is 11, and color of the car is white. And then price of the car is 11 lakhs. And then wheels of the car are 4. Okay. Now, this particular memory allocated to this particular object 3 is referred by this object reference known as HYI20 is the object reference. Okay. HYI20 is the object reference of this particular object, okay, to which memory is allocated. Now, four cars I am creating, 4 different type of real world cars I am representing here. What is that? Swift, Maruti Swift VDI, okay, SVDI, MS VDI, okay. I'll just give this object reference MS VDI. Just give that here. Let's give that object reference. Okay, and using this company, I'll say it as Maruti. Okay, Maruti Swift. Here, model is Swift VDI is a model. Swift VDI is a model, and mileage is like 24 kilometers, 24.32 kilometers per liter, and price of the car is 8 lakhs, let's say, and the color of the car is red color. Number of wheels of the car is 4. If you give all these different details for this instance, you see all these instance variables are holding different values. You see, first object is having Honda Amaze 14.59 lakhs, and all different values are there. And for second object, the class variables are holding different values. And for the third object, class variables are holding different values for this particular object, and hence they are stored in the object memory. And for the four, so here, how many are there? HMZ, BMW, X1. Okay, I think I have done some mistake here. I'll copy this and say Control Z, Control Z, Control Z, Control Z. Which one is coming here? Hyundai i20, Hyundai i20, Hyundai i20, Hyundai i20. Okay, this is what is the thing. And last one is this one, guys. Actually, car MSVDA. I just pasted here so that we have 4 cars here. Okay, each one holding the different type of values for this instance variables. And here, when I create an object for this, Maruti Swift VDA and all these things, some computer in the computer memory, some memory will be allocated to the object, and here object 4, for the object 4, some memory will be allocated, guys, to the object 4. The memory will be allocated in the object memory, guys. In the object memory, you will see that company is equal to Maruti, and model is equal to Swift VDI is a model, and mileage is equal to 24.32 kilometers per liter, let's say. And then color of the car is red color, and price of the car is 8 lakhs. I'm just giving some random numbers, guys. Okay, and the number of wheels of the car is 4. Okay, this is what is the mileage. Okay, values of the instance variables that they got stored, and the object reference for this object memory is MSVDI. MSVDI is the name of the object reference which is referring to this particular thing. Okay, that's all good, guys. That's all good. Now, guys, if you clearly observe, guys, company value is changing. Company is Honda for the object 1. Company is BMW for the object 2. Company is Hyundai for the object 3. Company is a Maruti for the object 4, which is changing for every object. So this company is eligible for being an instance variable. So it has to be an instance variable, because for every object, the value of this particular company is getting changed from Honda to BMW to Hyundai to Maruti, like that. Okay, model is also changing. You see, Amaze, X1, i20, and Swift VDA model is also changing. Mileage, what about mileage? Mileage value is also changing. 14.5, 12, here something like 11, here 24.32, like that. Mileage is also. Price, what about price? Price is also changing from object to object. 9 lakhs, 60 lakhs, 11 lakhs, 8 lakhs. Price is also changing. What about color? Color is also changing. Gray color, black color, then white color, red color. Colors are also changing. What about wheels? Wheels is equal to 4. Here also same. Wheels is equal to 4. Wheels is equal to 4. Wheels is equal to 4. No matter whatever the other variable details are changing, but wheels details are not changing, guys. So do you get a feeling like you are wasting the memory here for the wheels? Wheels is equal to 4. Every object you are storing the same value. Wheels is equal to 4. Wheels is equal to 4. Wheels is equal to 4. Unnecessarily, you are wasting the computer memory here by creating the wheels by using the wheels as an instance variable, because it's part of the object memory. Means it's duplicated here. You see, the same value is duplicated here. But for all the cars, wheels is called 4. Almost all the cars in India, right? Wheels will be 4. Okay. So that means these wheels shouldn't belong to some common memory. Object memory is not a common memory, guys. It's object specific memory. For a class, multiple objects can be created, and the memory for every object will be different. So these values will be stored differently. Why? Because they will keep changing for every object. But what about wheels, guys? It's a common value 4 is there, guys. We cannot make this wheels part of the object specific memory because we generally prefer to store the kind of variables whose value keep changing in the object specific memory, but wheels is such kind of variable whose value is not changing here. So what I can do is I can, whenever you create a class, guys, whenever you create the class, public class car like this, some memory will be allocated to the class. Okay, some class one. When you create a class, right? Some class one, I can write it here, like class one. Some memory got allocated for the class one, guys, and how to refer to this particular memory, guys? Using the name of the class. Using the name of the class, you can refer to this particular memory location. And now I don't want the wheels to be stored as part of the all these individual objects. Rather, wheels should be part of this common memory known as a this class memory. To make the wheels part of this class memory, to make the wheels part of this class memory, have to add a keyword known as static keyword before the variable. Static keyword before the variable. What if I give this static here, static keyword before the variable, and assign some value like 4 here? I don't have to initialize here, guys. I don't have to initialize this particular variable here anymore. Okay, just remove this initialization. For remaining all these things, I have to initialize, but for wheels, I don't have to initialize for every object. Okay, wheels, I don't have to initialize for every object, guys. And if I have to refer to this particular number of wheels, right, uh, directly you can use wheels here. Okay, you can use wheels here. That's one thing, one way. Or if you don't want to print here, let's say the wheels details you don't want to print here. Let's assume that. Okay, how to access? How did you access the instance variables, guys? Using the object memory, right? Using the object memory, you have access the instance variables. But wheels is no more a instance variable. It's a static variable because I mentioned static, right? Before the global variables, I mentioned the static keyword means it becomes a static variable, which is a common, which stores a common value and which stores the common value in the class memory. In such kind of situations, here I'll write down, instead of using the object reference, I should not be using the object reference to access the static variables. Static variables should be accessed with the help of the class name. So here I'll simply write down system.out.println car dot wheels. Okay, using the class name I have to call, guys. Okay, here also same thing, guys. I should not be using the object reference because object reference is used to access the variables which are of instance type. Okay, you can even access the class variables also, static variables also, but you will get some warning messages. It's not a recommended procedure actually. You have to access the static variables, which is a common which stores the common value for all the objects here. Okay, and stored in the class memory. Okay, those are called as static variables, guys. Okay, for all these cars, only the same wheel score is there. So why to waste the memory here? Why to waste the memory in the instance memory? Why to waste this instance memory here? Rather move this wheels into the this class memory by making that particular variable as static, right? You will move to the class memory and you can access that. Okay, so that is one difference. Other difference between the instance variables and static variables is, okay, accessing the, okay, we have to use object reference to access the instance variables. Okay, instance variables. Whereas what we have to use to access the static variables, we have to use the name of the class to access the static variables. Okay, these are some differences, guys. Okay, what is the difference between the static variables and instance variables? If someone asks you, right, instance variable belong to the object memory, which is a non-common memory, which is object specific memory. A class can have multiple objects having its own memories. So in that object specific memories, if you want to store the variables, you have to make that particular variables as instance variables, where the instance variable values will keep changing from object to object. In that case, that variable should be an instance variable. What if the value of that particular variable is common across all the objects? In that cases, you have to make that particular variable as a static variable, and it belongs to the class memory, which is a common memory and will be common for all the objects here. Such kind of memory is a common memory, which is a class memory. The moment you create an object, moment you create a class, right, this common memory will be created, and the static variables values will be stored in the common memories of the class. And how to access this? Static variables? By using the class name, we have to access. How to access this instance variables? By using the object reference, we have to access the instance variables. If you can explain this much of differences, right, you are good in the interviews. Okay, this is the knowledge that interviewers are expecting from you guys. Okay, as part of the, okay, a lot of definitions will be there, guys. If you just give the definitions, right, that will make the job, that will not make the job easier, guys. Okay, you have to make sure that you know the concepts, why we have to provide static, and what is the reason. Common values should be stored in the static memory, which is a class memory, whereas values which change from object to object for the variables of a particular class, that kind of variables we have to make them an instance memory, instance variables, and the instance variables should be accessed outside the class with the help of object reference. This static variables outside the class should be accessed using the class name. Okay, so if you can explain this much of differences, and with this example, if you can explain right in a detailed manner, then definitely the interviewer will get impressed. You can take the screenshot of this code, guys. You can take the screenshot of this code and practice in your machine. Okay, practice in your machine, and also you can take a screenshot of this memory allocation and all. Okay, why we have moved the wheels into the common memory, and that is class memory, and the static memory also we call sometimes. Okay, once we make this as static variable, it moves to the class memory. You can take a screenshot of this one also. Okay, so this one also you can take a screenshot, guys. You can take a screenshot of this one. Okay, like this, you can take a screenshot of this first particular stuff. Okay, okay, fine. So this is the thing, guys. This is the thing. I'll also provide this screenshot. Control A, Control C, and here in the notes I'll provide. Okay, this diagram I'll provide here so that you can understand what's the, why we have to make a particular variable as static variable. Wheels is one such superb example that you can give in the interviews to explain the interviewer that why we have made the particular variable as a static variable, and what is the difference between the static variable and instance variable. One more thing you can also mention is that both the static variables and instance variables are come under the global variables. They are created outside the methods and directly under the class. They are not local variables. They are global variables. If you put static keyword before the global variables, that will become the static variables. If you don't put static keyword before the variables which are directly created under the class, that is global variables. If you don't provide a static keyword, they are instance variables. If you can give all these things right, you know, they'll understand that you have profound knowledge on this static variables and instance variables in Java. So with practical demonstration and theoretical explanation, okay, I've answered this question for you. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between static and non-static methods in Java? Let me answer this question with practical demonstration. In order to give the answer for this particular question, where I'm going to explain and practically demonstrate the differences between the static methods and non-static methods in Java, I collected these 7 points, guys. Okay, this particular 7 boxes contains the answer for this particular question. Each and everything I'm going to explain in a theoretical and practical way at the same time. So let's get started with the first difference between the static and non-static methods. The first one is static methods have static keyword, okay, specified. Okay, in the method declaration, you are going to specify the static keyword. Okay, there is a keyword, a predefined keyword in Java known as static keyword is there, that if you specify in the declaration of the method, okay, that becomes a static method. Simple, right? And there is other method, guys. Let's say when you are declaring that method, in the method declaration, if you are not specifying or providing the static keyword, in that case, that particular method will become a non-static method. You can also call that as an instance method also. Okay, non-static is nothing but the instance method, object related method. Static methods belong to the class. Instance methods belong to the objects. So the methods which are specified with the static keyword are static methods which belong to the class, whereas the methods which are not specified in the declaration with the static keyword, they belong to the object, hence they are called as instance methods. Let me show you practically by creating some method here. Some static methods and some non-static, that is instance methods I'm going to create here. I'll create a package, guys. I'll simply name the package as .9. 9 is already there, guys. I'll go with the 10 then. 10, press enter. Yeah, in the package 10, I'm going to create a new class. I'll just name this class as, uh, some sample class, guys. Inside this sample class, I'm going to create method. Okay, I'm going to create methods. So first method, public void method 1. Public void method 1. Okay, public void method 1 I'll provide. And here I didn't specify any static keyword. In the method declaration, anywhere you see the static keyword being specified, static Java predefined keyword is specified inside instance, that is non-static method otherwise. Okay, instance method or static method. Okay, this is an instance or non-static method, guys, where in the method declaration we don't have the static keyword. If I create one more method, that is public void method 2. And in this method declaration, if I add a keyword like static keyword here, which is a predefined keyword in Java, then this particular method belongs a static method inside static method. Okay, the method that contains a static keyword is called a static method. The method that doesn't have contain the static keyword in the method declaration is called an instance method or non-static method. Okay, so these instance methods belong to the objects, whereas static methods belong to the classes, guys. You'll understand why I'm saying belong to the object and why static methods are belonging to the class and non-static instance methods are belonging to the object. I'll cover that later anyhow. Let's go with the next point, which will differentiate the difference between the static and non-static methods. Second point is static methods can only access the static stuff directly. Okay, static methods can only access the static stuff directly. What about the non-static stuff? They cannot be accessed directly, but you have to access them by creating an object. Okay, indirectly can be accessed. Non-static stuff inside the static methods can be accessed by creating an object for them. Okay, I'll show you guys first, and at the same time, non-static methods can access both static and non-static stuff directly. So for example, here, this is a non-static method, which is an instance method. It can access both static and non-static stuff. Can access both static and non-static stuff. What do I mean by stuff? Stuff means variables or methods. For example, here I create some global variables in a is equal to 5, into b is equal to 10. Here, before a particular variable, if I provide static keyword here, it becomes a static variable and it belongs to static stuff. And this particular variable is there. Okay, this particular variable is there, guys. This particular variable is not provided or specified with the static keyword. Okay, it's not provided with the static keyword. Hence, it belongs to the non-static stuff, that is object related thing. Okay, non-static stuff, non-static variable and static variable. Here, non-static method and static method. Okay, here I mentioned simply that a non-static method, okay, can access both static and non-static stuff. This is a non-static method which doesn't have the static keyword, can access both static and non-static stuff, guys. I'll create one more method, public void. You'll understand why I'm creating here. Public void method 3 I'll create and simply say system.out.println inside other non-static instance method. Okay, like this. Now, guys, I told you, right, from the non-static methods, you can access both static and non-static stuff. That means here, if I want to access this particular variable, which is a non-static variable, instance variable, you see, I can access. Any error is coming? No, I can access. What about this static variable can access inside the non-static method? Yes, I can access system.out.println b. I can access. You see, no errors at all. Now, from this non-static method, can access both static and static stuff. The static and non-static is not only specific to the variables, but also for the methods. So I want to call this particular method, which is static method. You see, method 2, I can access without any problems. From a non-static method, I can call the non-static methods. And method 3, which is a instance method or non-static method, can also be accessed. You see, both static and non-static stuff can be accessed from a non-static method. But what about the static method? Static methods can only access the static stuff directly. Here, both static and non-static stuff, okay, direct access is there. They can directly access the both static and non-static stuff. I don't have to create an object or something here. Here, coming to the static methods, can only access the static stuff directly. but access the non-static stuff, okay, object creation is required. I'll show you that. Okay, here in this static method, if I try to access this non-static variable, you see you will not be able to access, you'll get an error. System.out.println a, you are getting an error, right? You cannot access that. This is not possible. Directly, it is not possible. System.out.println b, I can access because static methods can access the static stuff directly. So without even creating the object, I can access the static stuff directly. That is, static variables or methods can be called directly without creating the object. But to access the non-static stuff like non-static variables and non-static methods, direct way is not possible, guys. I'll also show you how to, I'll try to call this method one, which is a non-static method from the static method one. Error will come. Cannot call it. You see, this is a non-static stuff cannot be called or accessed directly. Where about method three? Method three also you cannot access, guys. I have to create one more method, guys. Okay. Method 3 is a non-static method anyhow. Okay, that cannot be accessed. I'll create one more static method, public static void. Method 4 I'll say, and here I'll simply write down system.out.println inside other static method. Okay, like this. Now, if I want to call the method 4, I can call it, guys, without any problem. I can directly call, no error will come. You see, no error is coming. For method 1, error is coming. For variable A, error is coming because their non-static stuff cannot be accessed directly by the static methods. Then how to access the non-static stuff inside the static methods? For that, we need to create the object, guys. Okay, for that, we need to create an object. So the class in which this non-static variable and non-static methods are available, right? For that particular class, we have to create an object. So after sample is equal to new sample, like this. If you create an object for the class, then using the object reference, using this particular object reference, you can access. Okay, you can access system.out. Earlier, you were not able to access the variable a directly, right? Because it's an instance variable that cannot be accessed directly inside the static methods. But now sample.a I can access. Using the object reference, I can access. Simply sample.method. I can access the non-static methods also, method 1, or sample.method 3. I can access. Method 3, I can access. Okay, using the object reference, we have to access this. Using the object reference, we cannot access them directly. So hope, guys, you got some clarity here. Static methods can access only the static stuff directly, but in order to access the non-static stuff, which are instance related stuff, okay, we have to create an object. Whereas non-static methods, which are instance methods, can access both static and non-static stuff. It can be static variables or static methods can be accessed directly. No need of creating any object here. Okay, here, no need of creating an object. No need to create an object for anything. Okay, simple. Two differences are done so far with theoretical explanation and practical demonstration. I covered the 2 points. Now let's move on to the third point, guys. Third point. What is the third point here? Static methods belong to the class. Already I covered this. Okay. Static methods belong to the class. Instance methods belong to the object. That means, for example, if I create, for example, guys, I'll just make it look small here and create another class, guys. Let's create a new class. I'll just name this class as demo class. With main method, I'll create. So that this is a separate class from a different class. If you want to access the, okay, from a different class, if you want to access the this static variables and static methods within the class, you understood, right, how to access and all. Now outside the class, from this particular method, if you want to access the static variables and the instance variables, what is the process? Since non-static variables and non-static methods belong to the object memory, to access the non-static or instance stuff, we have to create an object for the class, guys. Outside the class also, we have to create an object. Sample s1 is equal to new sample. Like this, I'll create an object for the sample class, and using the object reference is here. You see, if I write system.out.println s1.a, this is a non-static or instance variable. Using the object reference, we have to access, guys. Using this is a s1 is object reference, and this is a chain. Now, if you want to call a non-static or instance method, using the object reference, you have to call, guys, method 1 s1 dot method. Then 2 is a static method. That's okay. We should not be calling method 3. Method 3 is a non-static method. Okay, this is how we can access static, non-static methods and non-static variables and non-static methods outside the class. But if I have to access static stuff outside the class, if I want to access the static stuff of that particular class, you don't have to create this object, guys. You don't have to create the object directly, guys. Directly, you can access them with the help of the class name. So simply, I'll write down outside the class. If I want to access the static variables and static methods using the class name, what is the class name? Sample dot t. You see, I can access the static variable with the help of the class name. Okay, whereas non-static variables and methods should be accessed using the object reference, for which you have to create the object, and using that object reference of the object, you have to access them. But for calling the static variables and static methods, for accessing the static variables and static methods, you don't have to do this stuff, guys. Simply use the class name and say method one, method two, you say, and similarly sample class dot method 4 also. Method 4 is also a static method. If you can see directly, you can access this with the help of class name. You don't have to create an object like this. Okay. So this is another difference, guys. This is another difference. Static methods belong to the class. Hence, using the class name, you can access the static variables and static methods outside the class. Whereas instance methods belong to the object. Hence, you have to create an object outside the class, and using the object reference of that particular object, you have to access the variables, instance variables and instance methods outside the class. This is the third difference, guys. With theoretical and practical demonstration, I have answered this for you. Now, fourth difference, that is, this keyword cannot be used inside the static methods. This keyword cannot be used inside the static methods. For example, this is a non-static method. So I want to return something. Return this, the object of the current. This means what? Object of the current class. The return type will be sample here. Okay. You see, I can use this keyword inside the method. What about this one? Static method. Can I use return this here? You see, even though if I say this is a sample also, okay, there will be error. You see, you cannot use this keyword inside the static methods. This means object of the current class. This means current object of the current class or current object of the class. Okay, you are referring to the, you're simply, instead of creating like this, right? Instead of creating an object like this, okay, in the short form, you are using this keyword, guys. Okay, this keyword you are using, okay, cannot be used inside a static context. Okay, you cannot create an object for the current class and use this in the static methods concept. This is not possible, guys. This is not possible. Okay, again I'll change it to what? In instance method, you can use this keyword. You see, this keyword can be used inside the instance methods. Okay, whereas in the static methods you cannot use, because this belongs to object concept, but static methods belong to the class. So conflict is there between the class and this object kind of stuff. Here instance method belong to the object, hence returning the object is fine. Returning the object of the current class is fine. Okay, because this is instance methods means non-static methods means object-related methods. So object-related stuff can be returned, etc. But here you cannot do that. Fine. There's another thing, guys. There's another difference between this keyword cannot be used inside static methods, where it can be used inside the instance method. One of the example I gave you already with practical demonstration. Now coming to the fifth difference, guys. Fifth difference is that static methods are loaded into the memory when the class is loaded. Okay. JVM to run the Java programs. JVM, Java Virtual Machine, is the one which is behind running this particular code. Okay, in order to run the Java code, the Java Virtual Machine component of the Java will load this particular class into the, okay, will load this particular class, guys, into the memory. Okay, static. So when the class code, that Java class related code is loaded into the, okay, memory for running the code and all, okay, along with that, static methods which belong to the class also will be loaded. Okay, during the compile time only. During the compile time only. Before the object is created only, the static methods are loaded into the memory along to run the Java class. Okay, JVM will load the class into the memory. Along with that class, right, static methods also will be loaded. You don't have to create an object in order to, okay, you don't have to create an object here. Before you create an object only, the static methods are loaded into the memory during the compile time itself. Okay, when you create a class and during compiling itself, before you run the code and all, what happens is when the class is loaded, along with the class, static methods also along with the class will be loaded into the memory, and they can be called using the class name, because of which you don't need to create an object to access the static variables or static methods. Whereas coming to the instance methods, they are loaded into the memory. Okay, JVM will allocate the memory for this instance variables and methods. Okay, instance variables and methods when an object is created, guys. Okay, here JVM will allocate. Okay, allocate the memory to this static methods along with the class, okay, when the object is not yet created, okay. While running the code, when before the object is created only, while the class is class details are being loaded into the memory for running purpose, static methods are also along with that being loaded. You don't have to create an object. But for instance variables and instance methods, okay, the memory will be allocated to them only when JVM, when an object is created only the JVM, okay, before the object is created. Here, after the object is created, that is after object is created only, after the object is created for the class, the memory will be allocated for the variables and methods, okay, which are instance variables and methods, okay. So this memory wise, these are the details, guys. Memory wise, these are the differences. Now coming to the next one, okay. Hence, after creating the object only using the object reference, you can access these variables and methods. But coming to this one, you don't have to need an object here. Directly using the class name, you can access. So when the class is loaded by JVM into the memory, static methods automatically will be loaded, and using the class name, you can access them. But to access the variables and methods, instance variables and methods, you need to create an object. Then only JVM will allocate the memory for this instance variables and methods. Using the object reference only, you can access that particular variables and methods. Okay. Next one. Next difference is static methods cannot be overridden but can be hidden, whereas instance methods can be overridden. Okay. First, I'll explain about the instance methods, guys, how they can be overridden. After that, I'll explain about the static methods. Okay. So here I'll create another example. I'll take is another example because this will confuse you if I give the code in the same one. I'll just create another package. I'll just name the package as new package levn dot lev11 package. Let's assume. Let's create a new class. I'll just name this class as class P. Some class P. Let's say class P. I'm going to make this particular class P as a parent class. That's the reason I'm naming it as class P. And I'm going to create one more class, guys. I'm going to create one more class. Here itself, I'm going to create one more class, guys. That is class C. I'm going to make this class C a child class of the class C. How to make this class C a child class of the class P? Extends class P. This particular extends keyword will, as part of the inheritance, will make the class C a child or subclass of the class parent class of the superclass class P. Once this extends keyword is done, now whatever the methods you create here, for example, in the class P, if I create a method like public void sample one, or sample method, if I create, let's say system.out.println inside sample method hyphen which class? Class P parent class. Okay. Here also the exact same copy paste method I'll create, guys. I'll just copy and paste. Okay. Anyhow, this particular method will be inherited by the child class, but still the child class is actually creating the exact same ditto copy of this particular method in the parent class. In such cases, we call this particular method as overridden method. Okay. If I add the override keyword, right, no error will come, means this particular method is really overriding the method in the parent class. Okay. So these methods are instance methods, guys. Instance methods can be overridden. Okay. Instance methods can be overridden. If you write @override, it confirms that instance methods can be overridden. Here inside sample method class C, I'll say, okay, this particular method belongs to the class C, which is an overridden method. Now, if I create another class, guys, if I create another class here, I just name this class as demo class. Just observe that, guys, what is happening here. Okay. So here we have the parent and child classes having the same sample methods, and the same sample method in the child class is said to override the sample method in the parent class. In such kind of situations, guys, if I try to create an object for the class C, let's say, okay, class C CC is equal to new class C. If I create an object for the class C like this, and using the object reference, if I call the sample method, which method will be called, guys? Child class method will be called, or parent class method will be called, because in the parent class also we have the sample method, in the child class also we have the sample method. When I say cc.sample, so what is happening here is ambiguity is there here. That means the same sample method is inherited by the child class from the parent class. At the same time, the child class has its own sample method, which is exactly matching with the parent class method. In such cases, the method which is inherited from the parent class will be called here by the object reference of the class C, or the method which is class C's child class its own duplicate sample method will be called here. Which one will be called? I will say that overridden method will be called. This concept is called as overriding, guys. When the parent class has the same method as the child class, and child class method is said to override the method in the parent class, In case of instance method, that is possible. And if you try to call the object using the object reference of the child class, inside sample method of class C will be printed here. That is child class related method is being called. What if I do something like this? If I try to create an object for the class P, CP is equal to new class P. In this case, I'm creating an object for which class, guys? Parent class. And if I use this object reference and call the cp.sample method, what will happen here? What will happen in this case? Here, directly you are creating an object for the parent class, and using the object reference of the parent class, when you can call the sample, right? Parent class is not inheriting any method from anywhere. It's actually is a parent of this class, but this is not the child of this class. So hence, directly this particular method of the parent class will be called inside sample method of class P will be printed here. You see in the second statement, you can see inside sample method class P got printed. That's also good. But there's one more confusing statement, guys, that a lot of people get confused. Like class P CP is equal to variable is object reference is declared with the parent class, but object is created for child class. This is possible in Java, guys. In Java, we can create an object using the new keyword. We are creating an object for the class C, but assigning that object to the variable of the parent class, guys. That's okay, guys. Okay. If I say, sorry, here CP is there, right? CP2, I'll say otherwise. Okay. So different name. CP2 dot sample method. If I call, which method will be called in this case? Here, object is created for the child class, but the object is assigned to the variable which is declared with the parent class. In such kind of situations, what will happen? Still, guys, because of the overriding concept, in this case also, even though the variable is declared with class P, but object is created for the class C, this overriding concept, with the help of overriding concept, right? The method that is specific to the class C will be called instead of the method that is inherited from the class P. Okay. The overridden method in the class C will be called instead of the inherited method from the class P. Okay. So here, child class method will be called, that is inside sample class C will be printed. This is inside sample method class C. This is all good, guys. So far, it is all good. What if I add static keyword here? If I add static key here, immediately I'm getting an error saying that overriding is not possible for the static methods. Exact same method. What did I do? I just gave the static keyword here. Okay, static keyword. Okay. So when I do that, static methods cannot be overridden. Static methods which are there in the parent class cannot be overridden. It's the same methods we cannot override. But if I remove this @ override, the error will be gone, guys. Overriding is not being done, but this concept is called as the child class can have the exact same static method that is there in the parent class, and this concept is not called as overriding. If you write the override keyword, right, you are getting an error saying that this particular method is not really overriding the method in the parent class. Then how it is possible to create the exact duplicate copy of the static method in the parent class? This concept is called as data hiding. Sorry, method hiding. Okay, instead of method overriding, method hiding, guys. This is called as method hiding, guys. So static methods will hide the data in the parent class, etc. Something like that. So in this case, guys, what will happen? If I say cc.sample, okay, I cannot, you see, I should not be using the objective. I should not be creating, okay, I should not be creating an object because to call the static methods, right? Why should I create an object, right? Why should I create? Warning messages are coming, error messages are not coming, but you understand, guys, when I create an object for the class C and using that object reference, I'm calling this, the static method which is there in the child class will be called. That's okay, even though it's not a correct approach, but still, I'll show you what is called as method hiding. So class P CP is called new class CP means method in the parent class will be called. What about this case? When you create an object for the child class and assign to the variable of the parent class, in that case, guys, using the object reference of this parent class declaration declared parent class and object is related. In this case, you may think that this particular method will be called, but parent class method will be called. Even though the object is created for the class C, which is child class, but assigned to the variable of the parent class, here parent class method will be called, guys. Whatever the type of the object reference is there, based on that particular method is called. Unlike overriding, okay, in case of overriding, right, when I say the same statement, right, it was calling the child class method. But in case of method hiding, okay, where static methods are, in the form of method hiding is being done here, same static methods. In that case, parent class, okay, whatever the object reference declared with, that particular method will be called. You will see that last statement will be different, guys. Last statement will be different. Class P is coming. Earlier, class C has come here. Inside sample method of class C came here in place of overriding, and static keyword was not there before this methods. But here, because of the method hiding, parent class methods will be called. But this is not the right way anyhow. If you want to call the static methods, right, generally how to call, you should not be creating an object, guys, directly class P dot sample, that's it. If you want to call the child class method, class C dot sample, okay. Okay. So this is no need to create an object here. No need to create an object. Dynamically, you don't have to create an object here. Okay. To get these methods being called, you can call them directly, whether it is parent or child, right? Appropriate methods will be called. Class P and class C got called with the help of class names. Okay. This is the best way of calling it. But if you still try to do this, you will get a different output when compared to the overriding. Static methods cannot be overridden but can be hidden. Instance methods can be overridden. I showed you because the instance method can be overridden. I was able to write the override method in the child class in overridden method. And this allows runtime polymorphism. Whatever the object that you are assigning to the object reference, right? That class object related method will be called. Okay. Okay, whether it is in parent, definitely child class method will be called, guys. Okay, that is called as runtime polymorphism. Whatever the class for which you are creating an object and assigned to the variable of either parent or child class interface, that child class doesn't matter, guys. It will definitely call the object class object created method, which definitely will be there in the child class or something like that. Okay, static methods cannot be overridden but can be hidden, guys. In this case, compile time polymorphism happens where the method calling will not depend on which type of object to which class you are creating object. Rather, the method calling will happen based on the declaration of that particular object, using which class you are declaring the object. Here you see, here in this case, using which class you are declaring the object, class P. That means in case of method hiding, the class using which you have declared its object reference, that particular method will be called, that is parent class method will be called here class P. In this case also class P is the parent class method will be called. In this case class C is the child class method will be called. Okay. But in case of method overriding, for which class you are creating object, that particular class's method will be called. Class C method will be called. Here class P method will be called. Here class C method will be called in method overriding. But in method hiding, that is in static methods, method hiding will be there. Method overloading, method overriding will not be there. In that case, okay, in static methods, the object reference declared class related methods will be called. And that's the thing, guys. That's another thing. Compile time polymorphism. You can call this kind of concept as compile time polymorphism in case of static methods. Okay, duplicating the methods in the parent class is compile time polymorphism will happen. In case of the instance methods, duplicating the method in the child class, that is called as method overriding, and that is called as runtime polymorphism. Based on the type of the object you are assigned to the object reference, such kind of method will be called, overridden method will be called, rather than the object reference declared class related method. Okay, that's object related class method means compile time compile time polymorphism. Okay, the last difference between the static and non-static methods. Hope you have learned a lot so far. Okay, so I'm static methods and instance methods. Okay, useful for creating the utility. What is the usage of static methods in real time? Why do we have to create static methods? One of the thing is for common. If you want to do some common stuff across the objects, for all the objects, a common activity you want to do. Okay, then all these objects, instead of creating separate methods, right, you can create a common method, okay, which can be used by all the objects. With the help of class name, you can call the common methods, guys. That is one purpose. Other thing is like easy. You use the easiness, guys. Easiness means, what is easy? Creating an object and using the object reference, calling a method is easy, or directly using the class name accessing is easy. Which one is easy? In this case, this way is easy, or this one is easy? By creating an object and using the object reference, calling the particular method is easy, or directly using the class name is easy? Using the class name, it will be very easy and readable, guys. So mostly in real time, right, whenever you need to call the multiple methods of the same class, right, okay, there are a list of methods in a class, and frequently you call the particular methods of the class, then you don't really like to create an object for the class, and using the object reference, you don't want to call the methods. Okay, but guys, when you create but when you make them static, all the methods, list of methods in that particular class, when you make it static, right, using the class name, you can access the methods. Okay, using the class name, you can access the methods. Okay, static methods can be accessed using the class name, which is very easy, guys. So utility methods, okay, in most of the cases, if the list of methods from a single class need to be accessed multiple times, right, in that case, instead of creating object for the class, right, we make all these particular methods of static inside that, and using the class name, we can access the methods, and that we call as utility classes or utility methods inside the utility classes. And two purposes are there here. Static method purpose are creating a common method or variable for the multiple objects and of the same class, and also for creating utility methods which can be accessed in any easy format. Okay, then instance methods. The purpose is to perform operations. Okay, whatever the methods that you want to perform the operations on the object related stuff, okay, which is not a common related stuff, object specific operations you want to do, such kind of methods you'll create for the object related operation. To perform the object related operations are called as instance methods, and the way to access the instance methods is only by creating an object for the class, and using the object reference we have to call that particular instance methods, guys. So these are the different differences that I wanted to cover as part of this session, guys. Okay, so that's all for this session, guys. So with practical demonstration and theoretical explanation, I gave good number of differences between the static methods and instance methods, that is non-static methods in Java. Hope you got good knowledge from this session. So that's all for this session. Thank you. Bye bye.